Welcome to your Unit 2 review. This will cover all of the pages in your review at the end of the packet. You will receive a packet in class, and the first few pages are pages you should have already done in class. So this video will start going over those, but if you've already completed them and checked them, you can go to the next videos. All right, this is page 26. Here we're going to be kind of focusing on formulas. So this is going to be for slope. You're going to see this one right over here. And basically the slope is the correlation multiplied by the standard deviation of the residual, the standard deviation of the y values divided by the standard deviation of the x values. The other thing you have to use is the linear regression, least squares regression line formula. However, understanding that the point always goes through the mean of the x's and the mean of the y's. So that'll help you be able to come up with the y-intercept, and then putting it all together, you'll be able to put it into the formula that you've grown to see a lot in this unit, which is y hat predicted y equals a plus b times x. You're not going to have to calculate standard deviation of the residuals or the correlation coefficient. That'll be provided for you, or you'll be able to come up with it from the coefficient of determination or something else. So let's get started. Question number 1, a random sample of 15 high school students was selected from the U.S. Census at School database. The foot length in centimeters and height in centimeters of each student was recorded. The mean and standard deviation of the foot lengths are x bar equals 24. So we know that x is the foot length. S of x is 2.71, so we're going to use those. The mean and standard deviation of the heights are y bar is 171.43, and standard deviation of those values is 10.69. We have the correlation, which is r equals 0.697. And our goal is to come up with the equation of the least squares regression line. So we're going to start with getting the slope. We have all the information we need to get that. So what we'll do is we'll write the formula down. And then we'll plug in our x and y values. That'll give you b equals 0.697 times 10.69 divided by 2.71. Calculate that out to get, we get b equals 2.749. Next, we're going to use the y bar equals a plus b x bar formula. So we'll use this one over here. Write that out. And then we're going to plug in everything but a. We now have b, we have y bar and x bar. So go ahead and do that. You get 171.32 equals a plus 2.749 times 24.76, which calculates to a plus 68.065. And then we subtract that out to get the value of a. And you have your value of a equals 103.255. So now we can write up our equation, which will be y hat is equal to 103.255 plus 2.749 times x. And it says to, it doesn't say to define the context of the variables, but you would want to make sure that you describe on a free response question that x is going to be your foot lengths and y is the predicted heights in centimeters. All right, you go ahead and do the next one and check it. This one would be a good thing to try on your own. So you could pause the video and then you can check it once you've done trying working it out. In this problem, the important thing is identifying the correct x and y variables. Notice down here it says find the equation of the least squares regression line for predicting a husband's height. So we're trying to predict the husband's height. So husband's going to be y, wife's height is going to be x. So once you've been able to identify that, you can go ahead and label your standard deviations accordingly and your means accordingly, and the correlations given here. All right, let's solve that out. And here we have our work here. Notice that I started with the the b again, so I got r times s of y over s of x, plugged in my 2.7 and 2.5 and 0.5 from the equation, from the problem stem, got 0.54. And then I transfer that over here, plugged in my mean, 64.5 for x and 68.5 for y, multiplied that out and subtracted. So here's my final answer. See if that matches up with what you have. All right, thank you.